you are going to see the projection, right? Then especially orthographic projection, right? Projection, first of all you should know what is projection, right? What do you, anybody can you explain what is projection? Suppose I have an object. Okay, the image of an object, if it is obtained on a projection plane or on a plane, then it is called a projection, right? You know this term already in physics. You have learned, right? In normal real projection is nothing but, suppose I have an object. If you are looking at the object, say this duster, so the image, it's nothing but the front face of this duster. You can look, this image can be obtained on the screen which is in the back side. That screen is nothing but the projection plane. I can say, if I have a principal projection plane, okay, in 2 dimension, so I have a object, it's nothing but a duster. So the image of this object, if an observer is viewing at the object somewhere here, right? The observer, if he views at the object, so the object he can see through his eyes like this, right? So the image you can see, this is nothing but the image I am obtaining at the principal plane, right? They see the image size and the object size which you are looking at. Okay, the object is smaller and the image you are obtaining on the projection plane is a bigger one, right? And see this is what, this is nothing but the two line, inclined line what I have drawn. This is nothing but person is looking at the object, okay, that is nothing but the observer. This is object, right? This is projection plane. This is a real projection. You can see here the image of the object, okay, the size of the object, image of the object, okay, the size of the image of the object, it depends upon the positions of the object and the position of the projection plane and position of the observer, okay. So normal projection, any projection, it will be like this. This is nothing but the rays of vision. So this is the image obtaining. Okay, you can see here the rays of vision depends upon the position of the object and the observer and the principal plane. In reality, the rays of vision will be in an inclined manner, it will meet the projection plane, right? That is a real projection. So you can make a note, what is projection? Obtaining on a projection plane is known as projection, right? A real projection. We will go to orthographic projection. What is orthographic projection? There is a difference between orthographic projection and an ordinary projection. So what do you mean by ortho? Perpendicular, right? That ortho means it is nothing but perpendicular. So which is perpendicular? We can say the rays of vision, if it meets the picture projection plane in a perpendicular fashion, okay, there will be an image. The image will, if the rays of vision meets the projection plane in a perpendicular fashion, right, then I can obtain an image, okay, a projection. That projection is called an orthographic projection, okay. So you can make a note, orthographic projection, if the rays of vision meets the projection plane in a perpendicular fashion, right? In a perpendicular fashion, projection plane in a perpendicular fashion, then the obtained projection perpendicular fashion, then an obtained projection is known as orthographic projection. Is known as orthographic projection. Right. So, in reality, is it possible the rays of vision? Is it possible? Can it possible? Okay, it is not possible in reality. What we have to make it real, what will be assuming something. Okay. So what we will be having some assumptions to have an orthographic projection. So can you say what can be a first assumption I have to do to make the rays of vision perpendicular to the projection plane?
These are coming from
infinite distance. If the rays of vision, if it comes from an infinite distance, right, that I can say the observer, I can keep it in an infinite distance. Okay, for an orthographic projection, to obtain an orthographic projection, the first assumption I have to take, observer is at infinite distance. So this is the first assumption I have to do to perform an orthographic projection, right? The second assumption, make a note, we'll see that there will be a projection plane to obtain any projection. Okay, we will be having projection planes. That projection planes are transparent. Projection planes are transparent. So that is the second assumption. The third assumption, projection planes are rotatable. Make a note. I can rotate the projection plane. Okay, that is the third assumption I am going to have to perform an orthographic projection. Right. So what is the necessary? We are going for an orthographic projection. Okay. So if I have an object, okay, it will be in any location. The observer will be in any location. To describe an object, I have to draw it in a three-dimensional way. Okay, to describe it in a three-dimensional way, it is difficult. What people doing, they will be drawing the various views of an object. Okay, various views of an object. To obtain various views, I have to go for an orthographic projection. So if I have this duster, to obtain the front view, I have to perform an orthographic projection, and that image of the front face will be obtained. That is nothing but the front view. If I want to see the top view, I have to look at from the top. I have to keep my projection plane below this. Okay, then the top view of this duster will be obtained on the projection plane. That is separately drawn. And for the side view, the side face, so what is the dimension it has, this duster, that I have to have another plane, in an auxiliary plane I have to introduce, and I have to show the side views, right? So describing an object in a three-dimensional fashion found difficult, so we are going for an orthographic projection. It is nothing but a two-dimensional views, so which will describe a three-dimensional object, right? A two-dimensional view which will describe a two-dimensional object. So I can say orthographic projection, it is nothing but I am converting a 3D to a two-dimensional views. Three-dimensional object, I am going to convert it as a two-dimensional views, right? Planes of projection. So I am going to have three planes, okay, to obtain the orthographic projection. Okay, the first plane is a horizontal plane, another plane HP, okay, the horizontal plane. I can write it as HP. Another plane is a vertical plane, write it as VP. The another plane I have an axillary plane. I can write it as AP. Okay, these three planes are perpendicular. You can see I'm going to have a plane, horizontal plane. This. So this is my horizontal plane. Okay, a horizontal plane. Then I will have a vertical plane. I will have a vertical plane. Okay, this is my horizontal plane. This is my vertical plane. Okay, so the intersection of this will give me a reference line. Okay. So in these two planes I will obtain my projection. Right. So having these two planes, horizontal and vertical planes. Right. So you can see these two planes will form four quadrants. I can say these two planes is forming four quadrants. Okay. So this is a quadrant, this is another quadrant, another quadrant and another quadrant. Okay. Suppose I keep my object in this plane, in this any one quadrant. So I can name this quadrant, okay, as this as a first quadrant, okay, this portion as a second quadrant, third quadrant or fourth quadrant. Okay. So this naming of quadrant, okay, defining the quadrant, it depends upon the observer where I am going to place. See here, suppose the observer is standing here and looking at the object in this quadrant. This will be a first quadrant. So in some books, this will be used as in first quadrant. Then where I have to keep an observer? Left side I have to keep an observer. Okay, then this will be first quadrant, this will be second, third, fourth. Okay, so depends upon the observer's position. Okay, the quadrant will be defined. Okay, this is the first quadrant, second quadrant, third and fourth quadrant. Right. Method of projection, orthographic projection. So if I keep my object in the first quadrant and if I perform the orthographic projection to that object, so that projection obtained is nothing but a first angle projection. This is when I am keeping an object here in the first quadrant. If I perform the orthographic projection, that is termed as first angle projection. This is a procedure method we are using. The same fashion in this, if I keep an object here in the second quadrant and if I perform the orthographic projection, okay, orthographic, then it will be termed as second angle projection. Similarly, if I keep an object in the third quadrant, okay, and if I perform the same orthographic projection, that is third angle projection, similarly, I will have a fourth angle projection. Okay, these are all the projections available. Okay, different projections. Okay. So the universally used projections are between first angle and a third angle. So the second and fourth angle is not used. Okay. Why it is not used, we will see. Normally first angle and third angle projection we are following. So in our country we are following the first angle projection. Some other countries they are following the third angle projection. Right? Is it clear? So normally the second and fourth angle projection is not used. Why? We will see that. Then we take the setup of this system of projection. Okay, setup in the sense. So I am going to have, this is the first quadrant here, after second, third and fourth. I am going to have an observer always to the right side. Right. So this is the setup I have. So the setup is nothing but this. This is the setup I am going to have. So you see here I have an observer, then I will keep an object then I will have a plane, projection plane. So as for the first angle projection, so I am having an object here. I am performing an orthographic projection. Now this projection is termed as first angle projection. You see here in this setup, for first angle projection, the setup will be observer comes first, then I will have an object, then the projection plane. So you should not violate to obtain any view in the first angle projection this setup. Okay, this setup should not be violated to obtain any views in a first angle projection. So the setup is nothing but observer comes first, then comes object, then comes projection plane. Right. So if I should have for a second angle projection, so what will be the setup? What will be the setup? Observer will be always standing in the right side. What will be the setup? Observer will be there, then plane, then object. Okay, the second angle projection. Similarly, you write for third and fourth angle projections. So observer, then projection plane, then object. Right. For third angle projection, I am going to keep my object in the third quadrant and I will perform an orthographic projection. The setup will be observer comes first, then plane, then object. Okay, for third angle, observer, projection plane, then object. Right. Then fourth angle, similarly to the first angle projection, so the setup will be observer, object, projection plane. Right. Is it clear? Is it clear? You see, I told if an object observer is standing in the left side, so the quadrant, this will be a first quadrant. Okay. I told if an observer is on the left side, the second quadrant what I have here now, that will be a first quadrant. Okay, what will be the setup here? Observer will be here. Object, then plane. So it's same one. Right. For the second quadrant. Okay, second angle projection. Okay. In another way, the observer will be here. Observer first, then object, then plane. As for this second angle projection in this setup. Okay. So anyway, so normally in all books what you are going to see here, so it will have a setup like this. Observer will be in the right side, then object, then plane comes. Okay, as for first angle projection, as for third angle projection, observer, then plane and object. So here you can see in detail the first angle projection. So the first angle projection, what is the setup? We will write the setup first of all. Because the setup you should have to obtain any view using the first angle projection. Okay. For a three-dimensional object, to obtain any view, you have to follow this setup. You should not violate this setup. Okay. Then your view will be wrong. So what is the setup for a first angle projection? That is, observer comes first, then object, then projection plane. Right. See here. I am going to have the first quadrant alone. This is my first quadrant. You see, this is nothing but my vertical plane. You have any. So this is my vertical plane. This is my horizontal plane. So the first quadrant I have in an orientation like this. See here, suppose this is an object, okay, observer is looking at the object. So this is the face I am interested. So the observer is standing, the object is next I have, okay, and I am going to perform an orthographic projection on a vertical plane. Okay, the observer is looking at the object in this way. Okay, it is nothing but the front side of an object he is looking. Okay, he is seeing the image of the front face, and it is obtained of the image of the front face on the vertical plane. Okay, if any projection, if I obtain it on the vertical plane, if this image I am obtaining it on the vertical plane, okay, this is nothing but this face is seen here. This projection is nothing but my front view. You make a note. Any projectional view obtained on a vertical plane is termed as front view. Okay, any projectional view obtained on a vertical plane is termed as a front view. Is it clear? Similarly, to obtain a top view, you see here, to obtain this top view, this face will be seen in the horizontal plane. Okay, the observer I have to keep it, okay, without violating this setup. Okay, to obtain another view, so I am going to obtain a top view. So without violating this setup, I am going to obtain a top view. So for this, the observer has to look at the object from the top. Okay, so the observer will be sitting there. It is the first one. Then the object is there. Then I have a horizontal plane in the bottom. Right. The setup is not violated, and I will be performing an orthographic projection from the top. The orthographic projection is performed, and this is obtained as a view. You see here, why I am drawing like this, see this lines will meet, will have a have the view. So this is my top view. So you will obtain a top view here. Okay, see here. Top view, you make a note. Any projection obtained on a horizontal plane is termed as a top view. Any projection if you obtain on a horizontal plane, it will be a top view. It is termed as top view, right? So one thing, this object, if it has some dimension, see here, so this object is having a cross section as x and y and the height as z, right? What would be the dimension of the front view? Front view will have hold the dimension of x and z. Okay, the top view will hold the dimension of x and y. You see the relation and see the link between these two views. Okay, these two views, front view and top view, it is in line, and the front view length and the top view length will have the same length. Okay, it is x length, and the top view and front view heights will vary. Right, now it is, I am performing an orthographic projection here, there is nothing but a first angle projection here in a three-dimensional setup. Okay, what I am going to do, I am going to draw this in a two-dimensional view. So the whole orthographic projection is to draw a two-dimensional view of any three-dimensional object. Okay, so I am performing a first angle projection here. I have got front view and I have got a top view. So this front view and top view, I have to draw it in a two-dimensional view. You see here, I am going to draw this front and top view in a two-dimensional manner. So if I say the intersection of this front view and the horizontal plane and vertical plane, the intersection is nothing but the reference line. The intersection of horizontal and vertical plane, I can name it as a reference line. Okay, I can notate it as x and y. Right. So if I tilt this same setup, okay, towards you, so what you can see above, you can see a reference line, and above that you can see a vertical plane. So I will have a reference line. Right. I will be having a vertical plane. Will be seen like this. So this is vertical plane, right? Then on the vertical plane I have my front view. So the front view is this. So it will have a dimensions of x and z, right? This is my front view. Right. So the horizontal plane, where I am tilting this, the horizontal plane will be matching with the reference line, and it is like this. Okay. So it is a three-dimensional setup. Okay, what is the third assumption? Go to the third assumption. Planes are rotatable. What I can do after performing these projections, okay, after performing these projections and obtain the view in the vertical plane and horizontal plane, I can rotate the horizontal plane 90 degree clockwise. Okay, I can rotate the horizontal plane 90 degree clockwise. If I rotate the horizontal plane this 90 degree clockwise like this, I can open it and I can see it below the reference line. So I will open the horizontal plane. I can see it below the reference line. So this is my horizontal plane, and the horizontal plane which holds the top view. Okay, holds the top view. The top view is having the this is again is x and it is y dimensions, right? So the planes, the second assumption is used after performing the orthographic projection. I can rotate the plane, that is that too I will be rotating the horizontal plane always 90 degree clockwise. Okay, in this setup, horizontal, if I rotate it, I can get it in a planar, in a plane, so that the front view and top view I can see it like this. Okay, vertical plane is above the reference line, horizontal plane is below the reference line. So you can see the views here, both the views, front view and top view, are in line. Okay, that is important. The front view and top view is in line, and you can see the front view length and the top view length both are same, but the front view and top view heights are different. And you should remember, as per the first angle projection, the front view will be on the above the reference line and the top view will be below the reference line. Now I can have a side view. I can add another view, side view. So the side view, so you see here, the side view, I should not, so I am going to obtain another view that is nothing but a side view. I should not violate this setup. Okay, I don't have a plane. Okay, I already had horizontal plane, vertical plane. I have front view and top view. I am going to introduce another plane to obtain a side view. That plane is nothing but an axillary plane. So I am going to see the object. Okay, this is the direction. This is the observer's front direction. So I am going to look at the object in this direction. So what kind of view it will be? Side view. Which side view this is? So this is the front direction. The observer looking at the object. You have got the front view. Right. Top view you have got. Suppose the observer is going here and looking at the object. So what side view according to the observer? Left side view. Okay, this is the front side. This is, as for the observer, this will be a left side. He is going to the left side and looking at the object. Okay, I am the observer. Object I have next to me. Then I have to place an plane. Okay, that plane is an axillary plane. So that axillary plane I am going to place it here. This is my axillary plane. So this is my axillary plane. Okay, this axillary plane, so observer is here. I can project this view in an axillary plane. See here, all the three views are linked. Okay, so that you can see here. So I will have a side view here. So what side view this is? This is a left side view. This is a left side view of this face. This is a left side view of this face. So is it clear? So any view, you can make a note, side view, any projection obtained on any projectional view obtained on an axillary plane, any projectional view obtained on an axillary plane is termed as side view, right? Side view. So already I have rotated the horizontal plane like this. Then in this setup I will have my axillary plane. Axillary plane will be sitting here, right? It will be sitting here perpendicularly. So what I can do it? Just this axillary plane I will be having vertically like this. Okay, I can open the axillary plane this way. I can open it. Okay, so my left side view, the axillary plane will come to the right side of the vertical plane. So I can open the axillary plane. So it will be coming to the right side. So in this one, I will have my left side view. See here. Again, as per the second, third assumption, planes are rotatable. The axillary plane also it is rotated. Okay, after performing the projection, and the axillary plane which in which I am getting the left side view, it is coming to the right side of the front view. You can see the dimensions here. As for this left side view concerned, dimension is having y and z, right? So this is my y and this is my z. You see here, the front view and side view will have the same height. Okay. Similarly, I can see here the height of the top view will match with the length of the side view. Okay, it will have a relation, so all the three views is related, it is linked. Okay, you should not draw it separately in a any three-dimensional object. You are drawing in two-dimensional views, they are linked together. Any views you are drawing, they are linked together. Okay, it will have a meaning. So the length of the front view and length of the top view matches. And similarly, height of the front view and height of the side view matches. Okay, similarly the height of the top view and length of the side view matches, right? And you can see front view and top view are inline vertically and front view and side views are inline horizontally. So always you can see, you can make a note in the side view, always the side views come along with the front view. Always the side view comes along with the front view. Is it clear? Here, if I have the same setup what I have drawn, if you are not able to visualize, okay, the drawing is first here. You see here, if I have an object here, so I am performing an orthographic projection. Okay, this is a duster, it will have x, y and z length. So you are looking at the object in the front direction. Okay, the front view is obtained on the vertical plane. This plane is nothing but a vertical plane. See here. This was the first setup I had. Right. So this is a vertical plane and this is a horizontal plane. I am performing an orthographic projection to the vertical plane. That view is nothing but the front view. The front view I have obtained here. So the same thing. The observer sitting on the top and looking at the object, he can see the plan of the top view of the object. Okay, that view is obtained on the horizontal plane. Now I am tilting towards you, so I am going to draw it on a two-dimensional one. So the front view you can see it as it is on the vertical plane, right? Top view is on the horizontal plane. I cannot see it as it is in a three-dimensional setup. So what I am going to do using this second assumption, I am going to rotate the horizontal plane 90 degree clockwise. So it will be as a plane sheet. So you will get front view and top view together vertically aligned. Right. The front view I will be getting above the reference line. Okay. Top view is below the reference line. The reference line is here. Is nothing but the intersection of the horizontal and vertical plane. Then I am introducing I have an object here. Okay, we have got front view and top view. To look at the object in the left side, so I have to introduce another plane. Okay, that is an axillary plane. Okay, in that axillary plane, I will be obtaining my left side view. Okay, left side view is here. Right. Once you have obtained the left side projection, so horizontal plane has rotated like this. Okay, in the axillary plane what you have on left side view, I have to open it like this. So the left side view what you have obtained in an axillary plane, it comes to the right side of the front view. Okay, this is the setup you have. So this you should remember as for first angle projection concern. Okay, this is the layout. Okay, so front view is here, top view is below the reference line and side view will come along the front view and left side view comes to the right side of the front view. Similarly, if I have another axillary plane here, I am looking at the object to the right side view will come to the left side of the object. So the right side view will come to the left side of the object. So again it is in line. Okay. One thing you should remember, these views are the representation of a three-dimensional object. Okay, you should not disintegrate this, you should not draw separately wherever you want. it will have some relation with other views. Okay, so it should be drawn as per the layout. If you disintegrate these views, it is meaningless. Okay, it doesn't convey any three-dimensional object. Right? Is it clear? That is an important one you should remember. Okay, all the views are linked together and it will have a meaning. Right? So that by reading these views, I can imagine the three-dimensional object. What is the three-dimensional object? So all the dimensions will be involved in these views. Right? So this is a first angle projection. This is the layout of the first angle projection. Make a note, layout of the first angle projection. Is it clear? Is it clear? Okay, you have any clarification you ask?
Sir, what about the rear view and the bottom view?
Rear view.
Sir, the object will also have a rear view.
Rear view, yeah. That is. Rear view where will come in there? Above.
Like we can't.
So this is a top view. There will be a bottom view. Bottom view I have to open it. Okay, the rear view what I have to do? It will be, take a box. Okay, fully closed box. The rear view you will be getting on another box. Okay, it will be coming to the left side you are. It will be coming to the right side. Okay. Imagine this is a horizontal plane. This wall is a vertical plane. Right. You can imagine this is a horizontal plane and this wall is a vertical plane. Right. You try to draw the, see here, you try to draw the front view of this board. Right. So like this. Right. The top view, the board is having some thickness and it is fixed on the wall. The reference line is nothing but this one. Okay, intersection of the floor and the wall. Okay, I am looking at the board from the top. The top view of the board is a small rectangular strip. That where it will fall? It will fall on the reference line. Okay, touching the reference line. The top view will fall. So the horizontal plane will be like this. Top view will fall touching the reference line. Is it clear? Okay, you remember this first angle projection. Take a note, first angle projection. Object will be, okay, the first note, object will be in the first quadrant. Object will be in the first quadrant. First angle projection in the sense object is kept in the first quadrant and I will perform the orthographic projection on the object, right? So the second note, so can you tell the position of the object with respect to the horizontal and vertical plane from the setup? So I had this setup like this, you see here. Okay, this is my horizontal plane, this is my vertical plane. I have the object here, observer is here. Okay, with respect to horizontal and vertical plane, what is the position of the object? The object is above the horizontal plane and
right side.
not with respect to observer, okay, in front of vertical plane. You make a note. The object is above, as per the first angle plane, the object is above the horizontal plane and it is in front of the vertical plane. Okay, that is the position. Okay. The third one, then setup. We may write the setup. Setup is observer, object, then plane. The setup you should not violate for first angle projection. Observer, object and projection plane. Okay. Then you draw this layout. Roughly you draw this layout. Front view where you will have the front view, where you will have the top view, and where you will have the side view. Draw the layout. Note here. Again you redraw it in a simple fashion. You redraw it. Above the reference line you will have the front view. Below the reference line you will have the top view. Then side views will come along with the front view. Okay. And that to the left side view comes to the right side of the front view. Right side view comes to the left side of the front view. Right. So one more thing here. Okay, this is about first angle projection. You can see here in this setup, these three views are linked. I told. Okay, how it is linked? Suppose I have front and top view details. Okay, the side view I can draw it. How I can draw it? You see here I am opening this like this. What will happen to this two plane? That is horizontal plane and axillary plane. Horizontal plane and axillary plane. It was like this and it is open. I am opening it like this. So it will have a link. Okay, that link is nothing but I have to draw a 45-degree line will separate. So whatever details I have in my top view, I can project it to the side view to get the side view. Right? Clear? So suppose I am opening it like this. So I can draw a 45-degree line. So whatever details I have in the top view, I can transfer it through a 45-degree line to the side view. Third angle projection. So as per the setup for third angle projection, what is the setup? The object will be at the which quadrant? Third quadrant. Okay, the setup will be observer, plane and object. Okay, object is at the third quadrant. Okay, the setup is observer, plane, then object. So I should not violate this. Okay. Then, as per this setup, you see here. So this is my third quadrant. Right. Object is here. This is my horizontal plane. This is my vertical plane. So what is the position of the object here? With respect to horizontal and vertical plane and the observer. Below the horizontal plane. In front of means observer is here. In front of means it has to be here. Either in the first quadrant or either in the fourth quadrant. Okay. That is behind vertical plane. The position you write. The object is at the third quadrant and the position of the object is it is below HP and behind VP, vertical plane. So the position of the object is below horizontal plane and it is behind the vertical plane. Okay, as for the observer concern, it is behind. Right. So without violating this, we will perform. Okay, we will have the right, we'll have my object. This is X, Y and Z direction. Okay, the observer is here. This is my, what plane this is? Vertical plane. This is my horizontal plane. Okay. To obtain the front view, I have to perform an orthographic projection on a vertical plane. I told any front view it is obtained on. Any view obtained on a vertical plane is termed as a front view. Okay, so the observer is here looking at the object. The front view I will be obtaining on the object. Okay, this is my front view. How this front view is obtained on this plane? Okay, I am viewing the object here. The plane is picture plane is in between, and I have the object behind the plane. How I can view the object? First of all, the plane is transparent. That is the third assumption. Second assumption is given. Plane is transparent. I can see the plane through the I can see the object through the transparent plane. I can obtain a view that is a front view on a vertical plane. Right. Similarly, for a top view, I have to perform an without violating the setup, where should be the observer? It should be, he should be on the top, looking at the object. So observer is first, then I have a plane, then I have the object. Okay, the projection I can obtain it. So we will have a length. Have a length. So I will have a top view here. Right. This is my front view. This is a top view I have. Right. On the horizontal. Any view obtained on a horizontal plane, it is a top view. Right. So as if now third view, third quadrant. Okay, it is like this. The third quadrant is like this. Okay, the object is here. The object is here. So this is my vertical plane, this is my horizontal plane. I am looking at the object. Okay, you are looking at the object like this, right? So in a front, the view is obtained on the front view, right? Then the view of the top view is obtained on the horizontal plane. Okay, from seeing from the top, the top view is obtained here. I can tilt it, I can draw it in a two-dimensional one. So what I will have, the front view I will have a reference line here. The front view where I will have? Below the reference line. As for that angle projection, the front view I will have below the reference line. So that is nothing but the vertical plane will come below the reference line. On the vertical plane I have a front view. Okay, on the vertical plane I have the front view. Right. Then top view is on the horizontal plane. What I can do it? I can rotate the horizontal plane 90 degree clockwise. Okay, 90 degree clockwise I can rotate. I can open it like this. The top view, that is a vertical plane, comes above the reference line. On the vertical plane I have a top view. So you can see in the third angle projection, the front view comes below the reference line and top view comes above the reference line. Okay. In first angle projection, front view comes above the reference line, top view comes below the reference line. Here, top view comes above the reference line, front view comes below the reference line. Okay, that is the thing. Then, to obtain a side view, so the object I have here, so I am looking at the object. Okay, this is the front direction, and this direction what I am looking is what? Left. Okay, left to the object. The left side view I am standing. Okay, I am looking at the object in the left side. So what is the setup I have? I am the observer. Okay, then I have an object. In between I have to introduce my axillary plane. So I will have my axillary plane here. I will have my axillary plane. Okay. So the projection will be obtained on an axillary plane. We will have a link. This is a left side view. Okay, this is the left side view I have on an auxiliary plane. Okay, now the same left side view. See here, you had a front view and top view. Okay, I am introducing, I have my object inside. Okay, to look at the object in the left side. Okay, this was your front view, front side. This is a top view. Okay, you are looking at the object to the left side. So I have to introduce an axillary plane. Okay, you will be standing here in the left side. So object is inside. There will be a plane in between. That is an axillary plane. On that plane I am getting my left side view. Okay, that left side view is here. So already you had a front view below the reference line. Top view by rotating the horizontal plane I had it above the reference line. And I have an axillary plane like this. I can open the axillary plane this way. So in the axillary plane I have what view? Left side view. You can see here, again, as I told earlier, the side views come along with the front view. Okay, front view is here. Side view comes along with the front view, and here the left side view comes to the left side of the front view. Here in third angle projection, the left side comes to the left side of the front view. That is the difference you have. Okay, as per third angle projection, vertical plane, I will have the vertical plane. This is my front view. Right, this is my front view. Right, then the horizontal plane, I am going to open it. Okay, it will come above the reference line. So the horizontal plane, I am going to open it. It comes above the reference line. So this is my top view. Right. So this is my horizontal plane. Right. Then the left side view, what I had it in my axillary plane, it is here. Right. So that I am going to open it to the left side. So the axillary plane comes to the axillary plane, and I will have my left side view to the left side of the front view. Okay, the left side view I will have it to the left side of the front view. Right. Similarly, right side view will come to the right side of the front view. You can see the difference. So the right side view will come to the right side of the front view. Right. So this is the layout for the third angle projection. You draw it. Right. You make a note. You make a note similar to the first angle projection. For third angle projection, that is the setup. The position of the object is below the reference, below the horizontal plane and behind the vertical plane, and it will have the layout like this. We are going to see how in our country whatever drawing we are going to use in companies, okay, they will be having drawn in first angle projection, using first angle projection. Okay, the views drawn as per the first angle projection. So the front view will be on the top and top view below the reference line. Side view comes along with the front view, that is left side view will be on the right side view will be on the left side. Right. Okay, make a note. Why the second and fourth angle projection are normally not used. Now before that, can you draw the same two views for the board using third angle projection? What will be the front view of this board? What is the difference? Okay, here in third angle projection you have to see this wall as a vertical plane, which will be a horizontal plane. The roof is a horizontal plane. Okay. For a third angle projection in your room, the wall will be seen as a vertical plane. The roof will be seen as a horizontal plane. Okay. The projection is obtained on a horizontal plane. It is open on the top. The top view will be getting above the reference line. The reference line will be the intersection of the wall, vertical wall and the roof. Right. So why we are not using second and third angle projection? Why we are not using second angle projection? You see here. So I am not drawing in 3 dimension. Okay, you know the 2-dimensional quadrant. The second quadrant, which is the second quadrant? It is the. This is the second quadrant I have. So this is vertical plane. This is horizontal plane in 2-dimensional. So which is the reference line I have? This intersection. Okay, the planes. I am drawing it in 2-dimensional. This is vertical plane and horizontal plane. This is my second quadrant. Okay, the observer is here. So what is the position of the object here? Setup is observer, plane, object. Okay, I am going to have an object here. What is the position of the object? Make a note. Position of the object. The second quadrant. Behind the vertical plane, that is then above the horizontal plane. Make a note. It will be the object position is above the horizontal plane and behind the vertical plane. Right. It is above horizontal plane, behind vertical plane. Now I am going to perform the orthographic projection here. You see just the two views. Observer is here. I am looking at the object. Okay, I have to get the front view. Where I have to get the front view? on the vertical plane. You know, any view obtained on a vertical plane, that is my front view. You see, suppose this is a front view I am obtaining on the vertical plane. So I will be getting the top view here. Okay, I will be getting the top view here. Right. You see here, this is the top view on the horizontal plane. So as per the setup, what is the setup? Observer, plane object. Top view, if I am looking at the object on the top, the setup is violating first of all. Object will come, observer will be on the top, then object, then plane comes. Okay. So I have to introduce a plane there. Okay, that is the first difference I have. So then for the top view I have to look at from the bottom. Okay, even though I have obtained the top view here, right, the setup is violating. Then even though I have obtained the top view as it is on the horizontal plane, violating the setup. Okay, suppose violating the setup, you see the front view in the reference line. This is my front view, this is going to be my front view. So this is my vertical plane. So I am tilting this, okay, turning this, okay, I am getting this, the front view. Then this horizontal plane, how I have to rotate it, how I have to open it. It should be open 90-degree clockwise. So if it is open 90-degree clockwise, what will happen? It will again comes above the reference line. Okay, have the plane like this in the second quadrant is this. Right, I have my object is here, front view is obtained here, top view is obtained here. So front view you have drawn, okay, front view you have drawn it as it is like this. Top view, I have to rotate my horizontal plane 90 degrees. Again it will, I have to fold it like this. Okay, the top view also comes above the reference line. My horizontal plane also comes above the reference line. My top view also comes above the reference line. If I have the two views above on the same side, so interpreting the three-dimensional object will be difficult. Okay, and it will get confused. Okay, two views I cannot have on the same place. Okay, that's why we are not using the second angle projection. You make a note. Similarly, the fourth angle projection I can say. This is my fourth quadrant. The object is here. Listen all of you. The object is here. I am performing the front view on the vertical plane. I am performing the top view on the horizontal plane. This is going to be my front view. This is going to be my top view. Right. What will happen if I see the front view? I can see it below the reference line. The front view I can see it below the reference line. So the vertical plane is like this. The front view is below the reference line. So my another plane, horizontal plane, my horizontal plane as per the fourth angle projection. Okay, this is the fourth quadrant. Okay, front view you have here, right? Front view you have here. The top view what you have got in this. Okay, it should be rotated 90-degree clockwise. Okay, 90-degree clockwise for you. It has to rotate it like this again. The top view, okay, horizontal plane will come below the reference line. So my top view also merged with the front view, and the front view and top view in the fourth angle projection both comes below the reference line. Okay, that's why we are not using the second angle and fourth angle. In second angle, both the views, second and fourth angle projection. The second and fourth angle projections are generally not used because both front view and top views, comes one side to the reference line. leading to confusion in interpreting the three-dimensional object, leading to confusion in interpreting the three-dimensional object.